Hi, I'm Jadi and let's continue LPIC1. Now we want to speak about changing run levels or boot targets and shut down or reboot the system. In the previous version of LPIC, this boot target was not here. But now with Systemctl, everywhere we had run level, the boot target is added. This is a new concept in the Systemctl. I will describe what it does. Candidates should be able to manage the System5 run level or Systemctl boot target of the system. This objective includes changing to single user mode, shutdown or rebooting the system. You should be able to, because candidates is you should be able to alert users before switching run levels or boot targets. And includes checking the default run level or Systemctl boot targets. You have to have an understanding of the upstart. You already have. So we won't go in that direction. It was another attempt to create an init system, which is not being used anymore. Weight is 3, which is high, and this is important subject. In normal life, you will encounter this a lot. But let's first speak and see what is a run level, or in the Systemctl vocabulary, boot target. If I want to give you an example, you can think about being alive or consciousness. This has different levels. The first time sperm reaches the eggs, you are alive this much, maybe not at all. On the next stage, I don't know, 5th month of the pregnancy, it's more like a live being. On the 9th month, you are born and it's a complete human, but you don't know much, you are not that much useless. You should go to you should not but useful. You should go to the school, learn new things, and you will start doing very important things. At the end, you will go downhill and maybe 90-year-old or I don't know, 100-year-old, you will get less and less alive. Maybe this was too dark. Same thing happens for computers. When you boot up your system, it goes through all the levels you know. Then you have the kernel. Then on one stage, it starts to load the main disk and starts booting itself. Then it activates other disks you have and then lets the root user to log in. Then multi-user. So different users can log in into the system. It's not only the rescue or emergency mode for root user. Then it goes to, I don't know, networking, and networks start working. Then it goes through the GUI login, graphical user interface login. And if you have a server, web server will start running. DNS server or whatever server you have will start working, and at the end, in some place, you will shut down the system. And you were booting it here or rebooting it here. See, we have different stages of the system, and a Linux machine can traverse between them. For example, if you are in a GUI system with login, you can decide to switch back to multi-user. The GUI will go down and multi-user system will accept people to log in. If you have a problem on your system, you can tell it, I don't want even the multi-user. I want to go only single user mode and I want to check, give you the root password. If I provide you the root password, you let me in and let me check what is going on the system. Or if you have a web server, you don't need the GUI. So you will omit this part and you will start your web servers. These are different levels of the consciousness, being alive, of a Linux system. This used to be called run levels on System5 systems. Now on Systemctl, we have boot targets. You already have seen boot targets. Let me go to the Ubuntu we had. On my Ubuntu, I will run a terminal. We forgot to show you how to fix the size, but no problem. Sudo su, I will give it my own password. Now I'm root and I can give higher rank commands. I have more access. Systemctl list units, type is target. I will ask it to show me all the targets. Each target is a combination of services. So when I have a target, it means some specific services are running there. And I can arrange my targets, I can configure my targets, make them being dependent to each other. This target should run after that one. You've already seen this in the previous section. For example, I have a basic target. It's a basic system. I have a crypt setup. This is a target where basic system is working and encrypted volumes can be used. I have a getUI, which is a login prompts. I have a graphical target. This is a graphical interface. Remember, these are just names. This doesn't show the hierarchy. You can check any of them like this. For example, I have one multi-user. Can you find it? It is gone. It's here. Multi-user. I can say systemctl cat multi-user. It will show me the configuration file for multi-user. It says multi-user. This is the name. It requires basic target. So run whatever I had in the basic target first. This conflicts with the rescue target and rescue service. So you cannot be in the rescue target and multi-user at the same time. But it should run after basic and rescue. So the system goes to basic, rescue, and then change to multi-user. They cannot run simultaneously. And allow isolation is yes. I can say isolate this. I only want this configuration. The problem and the good thing about systemd is, as you saw, each target have some configurations, runs some things, comes after something, requires some things, conflicts with something. So each target has some specific services, and at the same time, some services can be active with each other. So you can be in a networking configuration and GUI configuration at the same time. You can configure them to go up and down. So on a systemd, you can have different targets. Each target does something. You can configure them to be online at the same time, or bring one down, bring only the networking down, and this kind of stuff. You can always check systemctl, check default. Sorry, what was it? Get default. Get default, and you will get the default target. So on this system, graphical target is the default target. I can say systemctl cat graphical target, and it will give me the configuration for the graphical. It says this requires multi-user. You remember, multi-user required basic. So basic should run, then rescue will run, then rescue should not run, and we will go to the multi-user, then we will go into the graphical. And during the graphical, it comes only after multi-user, rescue, display manager should be running, and you can isolate it. I will show this isolate thing later. You see, I can create different things and start them and stop them. And I can always check the status, just like a service. I can say systemctl status of graphical target. It means, okay, graphical target is active. I can say systemctl status multi-user target. That's also active. I can say systemctl status rescue. It says rescue is no loaded but inactive, because you remember it was conflicting with the both graphical and multi-user. So when you're switching to this, that will be disabled. This is how you can arrange services on different levels and switch to them. I can create one target for myself, say servers up. In the configuration, I can say run the web server, run the DNS server, run the FTP server, and it comes after multi-user and networking. So if I start it, it will check multi-user should be running, networking should be running, and my target will work. But because of this complication that things are like a mesh and it's difficult to say I want to go to multi-user only, the Systemctl has some very specific targets for itself. By default, you can go to the rescue mode, emergency mode, reboot, halt, or power off to control your machine. On the rescue, it's for rescue. Local file system are all mounted, all disks are working, there is no networking, and only root user works. So only root user can log in. It even doesn't ask for a username. It will tell you, provide the root user's password. On the emergency, which is more emergent than rescue, only the root file system and in read-only mode. Other parts are same. No networking, only root. Reboot will reboot the system. Halt with halt the system. Power off with power off the system. What's the difference? When you do a halt, it stops all processes and then halts CPU activities. All the processes will go down and CPU will stop working. The power is still there. If you do a power off, it's like the halt. All the processes will go down, CPU will stop working, and then shutdown signal will send to ACPI. We will see this later. So the power will be off on the motherboard. If you have lights, it will go off. There is no power in the motherboard anymore, at least in the CPU. So this is the difference. And reboot will bring all the processes down, will stop CPU activities, then will start everything again from scratch and system will reboot. As you saw, we had a configuration here which was saying isolate is yes or no. If I was checking graphical, it was saying allow isolate, yes. This is a way to switch between targets. On my Ubuntu system, I can say Systemctl isolate the multi-user for me. Multi-user doesn't have a graphical interface. So if I switch to this target, I'm in a multi-user non-graphical system. I can log in. I can say I'm Jody, this is my password, and I can work. I can say Systemctl isolate rescue. It will go to the rescue target. It will tell you authentication is required to start rescue. Authenticate as Jody. Now it's asking only my password. I will give it my own password because changing the targets, especially going to rescue, needs the root access. Now it says, okay, I've changed my target to the rescue. Press enter for maintenance. I will press enter and I will in a root state. That's why it was asking for the password. So now I'm in rescue mode. I can even go deeper and say Systemctl isolate the emergency. It says, okay, press enter for emergency. Now I'm in emergency mode. Even less services are running. At least the disks are not mounted. And I can go back as always. I can say Systemctl isolate multi-user, or directly I can go to the graphical and I will switch back to the graphical. It will read the graphical configuration, will bring all the required services, which include the login and the graphical interface. This is how you switch between states of the system. So, and also, as you saw, we had the target like reboot shutdown. So I can say sudo Systemctl isolate the reboot. Tell you unknown command isolate. It isolated the reboot. So now I'm in reboot state, system will come up and it will go to the default one, which you used to get with Systemctl get default, which was graphical. So it will boot into the graphical state. This was it. But let's talk about System 5. I'm sure you will even get a better understanding, although we have very few distros who use System 5 nowadays. In System 5 days, it was not like a mesh with different targets which could have been dependent to each other, conflicting things before, after, nothing. On Red Hat systems, you used to have 7 levels of Runlevels. That's why it was called Runlevels. 0 was shutdown, 1 was single user mode in recovery, also called S or S. As you remember, you could give this as a kernel parameter to the grub to boot the system in the single user mode. We'll see this later in the grub section. Level 2 was multi-user without networking. Level 3 was multi-user with networking. So networking is up. 4 was empty. So you could configure your services here. If I was a system administrator on a Red Hat system, I could say that in level 4, I want my HTTPD service to be running. This is a web server. So web server was running on 4 if I configured it. In normal, it was empty. And 5 was multi-user with network and graphics. So I could say, go to level 4, which means go through all of these in addition to my HTTP server. So that would be a specific state of a server for myself. I could say, switch to 5. The command was init 5. And then it was running whatever needed here. I could also say init 6 and it would reboot the system. Or I could say init 0 and it would shut down the system. So in any case, this was how Red Hat used to work. I will show you a little bit more about it. In Debian systems, we used to have this. 0 was shutdown, same. 1 was single user mode, same. 2 was multi-user mode with graphics, just like 5 here. And we didn't have 3, 4, and 5. You could configure this for yourself. This was the default configuration in most of the distros and doesn't reflect the general obligatory configuration. You were able to change this. What happened here? It's not booted. Let's go to our Fedora. Now let's continue with this in this section. In the System 5 era, we used to have the Runlevel command. So Runlevel would show you which run level you are in. Let's start our Ubuntu. Even in System D era, these commands are most of the time still present, but they are reflecting the systemd system. Because some scripts may use them, some system admins may use them. So for the backward compatibility, still you can issue these commands: init, runlevel, tell init, and everything. Let me run a terminal. So if you say sudo su become root, these are important commands. If you say run level, it will tell you run level. It will tell you that at the moment I'm in run level 5. Previous level was n, nothing. I don't know, none, whatever you say. If I say init 3, it would go to run level 3, which was a multi-user here. I can say Ubuntu have changed this, as you see. It's not like a Debian. I can say init 5 again, go back to, it says, okay, you need root access. I will use sudo to increase my permissions. I will go back to the graphical mode and give it a password. All the other programs I had previously is closed because I went to init 3. So the whole graphical system is dead. But now it's back, a new one. So if I say run level now, it will tell you you were in 5, you were in 3, now you are in 5. So it shows current and previous one. This is the current one. Same command with init was tell init 5, switch back to 5, nothing changes because services were running. But how system 5 used to work? On the etc, you used to have a directory initd. Here you had all these services. You saw in the previous section. You saw this in previous section. For example, GDM is a graphical login. It's a service. It's a simple, not very simple, but it's a general script which accepts start and stop or starts that service or restarts. How you used to create these from that etc initd. Here you had some services. For example, GDM for graphical login, GDM3. You want to say, okay, on run level 5, I need this to be running. On the system 5 era, you would go to etc rc5d. This is a directory which says what happens on level 5. You have different files here. And you have GDM3 with a S in the beginning. So it says start GDM3. If you go to for example, RC6 is for reboot, right? If you go here, everything has a kill. It starts with a K. It's a link to those files. lsltrh. You can see that. For example, it says kill open VPN. It's a link to etc initd open VPN. So it kills this. Very, 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 I don't know, primary, Unix-like, old school, rough. But we had some files in etc initd which could start and start services. And in each directory of each level, you would create a link to that file with a K in the beginning or with a S in the beginning and a number to show the priority. All are 1, so it says I want all of this to be done at the same time. But when you have the start, it would start it. So just the link and which says on which level I want to do what. Fun, easy, very straightforward, but not very, very, very strong. The last file you should know about is etc init tab. I think nowadays we don't have it anymore. Less init tab. We don't have it. But I have a copy for you here. etc init tab used to tell the system 5, we are speaking about system 5 as you know, how to boot the system, which level is the default run level. It used to have a line like this. It says ID 5 init default. ID and init default was should have been these, but 5 would say 5 is the default run level. So you should go to RC5D, see whatever is running there. Also check 4, 3 and start whatever was there. So it was a hierarchy. You could not create a mesh and create with this one, you could not create a graphical without networking. You had to create your own level, copy files, stop something. But on a systemd, you can say stop networking and networking would be stopped. It doesn't need to be a hierarchy. Anyway, I believe you know more than enough about the systemd. Let's go to another section and we will speak about stopping and starting. No, just stopping the system and informing people about stopping.